Testing, testing, 1, 2, 3. Pardon me. I suppose I should have got that out of the way before I turned my camera on, eh? Anyway, hello. Greetings. Hello and greetings. Oh, what piece is this? That's a good question. What is it? Let's see. Media source. It is... Piano Trio number 7 in B-flat major op 97. That's what it is. So, still got that tinniness in the microphone. I'm not sure what's going on with it, but who knows. Yeah, anyway, how's everybody do? Uh-oh. Uh-oh. There we go. Hopefully. Oh, boy. Hopefully we managed to avoid the types of technical difficulties that we were having last time. God only knows, though. Hello, everyone. Files are objects, just like everything else in Python. Conclusion, there's nothing new to learn. Everything is an object, and therefore nothing is an object. Yes, now that you know what objects are, that's all I have to teach you. Since everything is an object, you're done the course. No, that's not true at all. No, file I/O is, it's its own subject. Once again, I sort of put file I/O in the same camp as the testing and exceptions material. It's not as new as, it's certainly not as new as the classes stuff, which is, you know, probably not many of you have done object-oriented before. So the, yeah, file I/O is really, like, once you understand what a file stream is, it's not that bad. Is the audio cutting out? Hello? Just try resetting things once again. Seems my mic is good. Let me do a clap test. I haven't usually had to do clap tests, but let's do a clap test. This was more of a problem last semester before my internet got fixed. But, I can see it, like, the compression is really bad today, too. Yeah, the sync is coming through fine for me. Huh. Yeah, I don't know what to say about that. I can't resync. I can't perform a manual sync because, to me, like, in the feedback I'm getting here, there's no sync problem. So I can't. It's again that problem. You can't fix a bug that you can't reproduce, and I can't reproduce that bug. So, I don't know. Maybe it's just a whole bunch of internet usage today. The stream seems really poor quality today for whatever reason. But can I stream in high definition? No. No, there's nothing for that. Okay, well, it is what it is, I guess. There's nothing I can do about it. Anyway, so, yeah, we'll finish off classes today. We were just about finished classes. So, yeah. Incidentally, quick announcement before we get started. There you go. So, apparently, if you refresh your stream, then everything will be fine. You can even play the stream, like, you can watch the you can watch the stream slightly desynced with it actually being transmitted, you know? You can, like, if you can go back a minute and then watch the stream as if it were fine. The only thing is it desyncs the comments slightly. But, anyway, important announcement. I'm moving my office hours today from immediately after this class to the same time in the day tomorrow. So I'm moving my office hours to Friday, which is tomorrow, because I've got a thing. So, yeah. So just be aware of that. I'm going to be doing my office hours tomorrow. So, yeah. Cool. Hopefully that's fine. There is not a test this week, so I don't expect many people were planning on going to the office hours anyways. But anyway, so we were talking about, so we had just finished the mean calculator example, which, like, the idea, once again, the idea with the two different ways of doing the mean calculator, one of these ways of doing the mean calculator, we kept a list that contained every value that had ever been input to the mean calculator. That's one way of storing that data. Another way of storing that data is to keep running sums of both the sum and the number of elements in the hypothetical list that doesn't exist. This allows you to perform the same calculation without, you know, the excessive memory usage, one might say, from maintaining a list of all of the things that have been entered. The only thing is, if you're concerned with more, you know, if you later wanted to take this thing and expand it to a more general-purpose statistical package, and perhaps add something like standard deviation as well as mean, the mean calculator 2 would no longer be capable of supporting that type of functionality because it's simply it doesn't keep track of the required information to be able to do that calculation. The same way it would not, like, this mean calculator would not be capable of calculating mode or median, for example, whereas mean calculator 1 could hypothetically easily be extended to calculate median and mode in addition to mean. And that's actually like a general trend that you'll find in computing. and this is kind of getting into more advanced stuff, but or like a more considered approach to computer science as a problem, or even problem solving in general. In general, in computer science, it's more difficult or resource intensive to solve the general problem than the specific problem. So when, like, I would consider Mean Calculator 2 to be solving a more specific problem than Mean Calculator 1, right? It just calculates the mean, whereas Mean Calculator 1 might calculate mean, and it might, like, because it's more general in its purpose, it can be adapted later on to solve a more general set of problems. Of course, you're going to pay for the generality, and, you know, computer scientists, you know, grad students and people of that nature are often, like, torn between the accomplishment of the specific algorithm that solves a specific problem and the general algorithm that solves general problems. And generally speaking, it takes more time and effort to solve the general problem than the specific problem. You know, but anyway, so the whole idea, roughly, of classes is that we are providing data abstraction at the same time as functional abstraction. So we don't need to know whether the mean calculator class that we're using is implemented in this manner or in this manner. It doesn't make a single lick of difference to us, the user of this class. It certainly makes a difference if you're writing the class, but from the perspective of a person who is, you know, imagine yourself in a work environment, right? You're responsible for, you know, X, Y, and Z functionalities of a piece of software. X, Y, and Z require classes A, B, and C that were written by, you know, one of your work colleagues. In order for you to effectively write X, Y, and Z, you don't, like, the ideal case is that you don't need to know anything about how A, B, and C are implemented. That's someone else's task. What you need is you need A, B, and C to have consistent and reliable interfaces. As long as they are consistent, the interfaces are consistent and reliable and can be used effectively by you, it doesn't matter how exactly A, B, and C were implemented. You can abstract that from your brain. You don't need to worry about those details. So that's, you know, this is getting into design theory and stuff like that again. Like, the idea, one of the basic design principles of software design is called the principle of least privilege. And that's the idea that you should have access to only that which you need to accomplish the task. Because if you have access to more than that, then you're likely to mess things up, right? It's like, and this is actually getting into the next section on hiding methods and members. So, to draw an analogy, let's say for a moment that you are a car mechanic, right? Let's say you're a car mechanic. If your job is to, this analogy isn't going to work very well, but I'll plug away anyway. Let's say that you're a car mechanic and you have to replace a spark plug, right? Now, when you replace a spark plug, do you have to, like, dismount the entire engine from the car? You know, do you have to take the car completely apart in order to be able to change the spark plug? No. For example, why would you dismount wheels from a car when you're just changing a spark plug? You don't need to. Incidentally, if any of you don't know how automobiles work, the spark plug is the component on the engine that sits on top of the cylinders that ignites the gasoline inside of the cylinders that provides the explosive force that sort of exerts force on the piston. The piston turns. The piston apparatus turns that explosive force into a rotational force, which is then, carried by the main shaft of the engine to the wheels and what have you. So it's a small piece that sits on top of your engine block, typically speaking. So, and you'd have one for each cylinder. So with spark plugs, you don't need to dismount the wheels to change a spark plug, right? All you need to do on, a typically constructed car is, like, pop open the hood, remove the, if your engine has like a cover plate over the engine block, you need to remove that so you can get at the spark plug, and then you just change the spark plug there. So the idea is, the thing I'm trying to get at here is, from one perspective, when you're changing the spark plug, the correct mental frame there is to have your brain hide from you all of the complexity of the machine that's not related to the spark plug, right? So your brain kind of automatically, if you're working on this car, your brain's like, I don't need to worry about the brakes, so I'm not even going to acknowledge that they exist right now, right? I don't need to worry about the radiator because it's not related to the task at hand. I don't need to worry about it. I can't even see it right now unless I perform more disassembly of the engine compartment. So, or maybe you can, but whatever. You get what I'm saying. So the idea is, reduce the complexity of the machine to the complexity of the needed operation. So, in general, when we're designing software, we try to design software along similar lines. And I know it's kind of a weird analogy because software is not at all a physical system, but that's, to some degree, that actually works against you. It would be in a sense, it would be easier if your software were some physically existing apparatus, because human beings have this, like, inbuilt mental capacity to exclude areas of a machine that they're not working on, right? You don't even have to think about not thinking about your brake discs while you're changing a spark plug. Your brain just automatically does that for you, because that problem is, like, similar to the sorts of the sorts of tasks human beings had to evolve to be able to do, right? The problem that you have with software engineering or software in general, is that it exists inside of this abstract virtual realm for which human beings are not adapted, right? So it's very, very easy. It's much easier in software to sort of fall down a rabbit hole of things that are unrelated to the task that you want to perform, especially if you start noticing errors in parts of code that you're not currently working on. You can easily sort of spiral into this, endless cycle of code modification, and sort of even forget the thing that you're working on. Perhaps some of you have experienced this during the assignments themselves, although the assignments are usually small enough that this isn't a big concern. So, so in the same way that a car hides parts of itself from your attention, you can do the same thing with software. Actually, I just thought that a better analogy would be the driver of a car. It's... When you're driving a car, you're presented only with the interface consisting of the steering wheel, the pedals, and the gear shift, and, the blinkers. You have a small, limited interface to the machine, right? It's not like when you're driving a car, you have to climb into the engine compartment and manually shift you know, gears around in order to change the gears. You just have a little interface that allows you to shift the gears right from the cockpit, which is, you know, super, super useful, and in fact, the only way that that would actually work, or the only way that that could work in a physical sense. So, essentially, the analogy to software is that all of the parts of the car that are not in the cockpit, or the driver's seat, are private, and all of the interface pieces inside of the cockpit, those are public. That's the public interface to your vehicle. And all of the stuff going on behind the scenes that makes the vehicle actually work, those are all private. It's implicit because it's a physical system, but I think that's a pretty good analogy. Let me see if I have any questions. My camera froze. Will A8 be on classes? I don't know. I think so. I think so. Pretty sure. Oh my goodness. Once again. At least it's not a super stupid face this time. Okay. So, we can make elements of a class private by prefixing them with the double underscore by double underscores. So, this prevents anything outside of the class from accessing either the attribute or the method. So, in the case of the final mean calculator, we are making the sum and the count private. This means that they are not viewable outside of the class, and it also means they're not modifiable except by the methods of the class. So, you can imagine if some sort of nefarious software developer knew the structure of the class because he looked it up or something, he could modify class properties directly in ways that you didn't intend the class to be used, and, you know, thereby introduce bugs because things aren't being used in the manner in which they were designed. So it's kind of like using a wrench as a hammer type thing. Making these things private means the only way that they may be modified is via the methods of the class, which are public. So this is a mechanism for controlling access to the members of a class, which is, you know, in the same way that the steering wheel controls access to the tire assembly, this controls access to the data inside of a class. So yeah, in general. And there's this fun bit at the end of this lecture where, so yeah, let's not dwell on this too long, but let's dwell on it a little bit. So video games are pieces of software, as you might expect. Within the context of a video game, video games are often developed in an object-oriented manner. So, what are some objects, what are some classes that we might have within the context of this Mario game? Take a moment, please, to enter that into the chat, and I'm just going to get the next slide set loaded up. Oh, I've got a question, too. So I've been thinking about classes as equivalence classes in math, where you have to define specific relations for specific classes. You can't perform integer addition on a class of car models. Yeah, that's no, that's not a terrible analogy. Like, it's like, you know, division does something different when it's applied to integers as opposed to floating point numbers, right? If you consider each class to be its own data type that can have its own modified functionality, then yeah, that's not a bad analogy. Coins? Yep, coins would be a class. Is it kind of like you can design all the character movements and then just change the character that does them? Characters are all classes. Mystery boxes. Yep. So, within the analogy, within this, sort of think about things in various, like, you know, if I were to design a Mario game, I would begin by roughly categorizing the things in the field of play as, you know, I'd put them in a few major groups first. Like, bricks and question mark blocks and used question mark blocks and the ground and warp pipes and, you know, one-way platforms. All of these types of things are, I guess I would consider them to be platform blocks, right? They're sort of, they're blocks that interact with the physics engine, right? They're barriers with respect to physics, and there's a whole slew of these different types of blocks in a Mario game. Coins, I would consider to be coins, mushrooms, fire, flowers, all of those types of things. I would put those in another class that would be for collectibles, right? Or like things that disappear when you touch them. They might interact with the physics blocks, but they only interact with, like, the player character blocks insofar, or they only interact with the characters insofar as when a character touches them, they disappear, right? So they all share that functionality. I would, like, things like Goombas, Koopas, Piranha Plants, etc., those roughly would be enemies, you know, and you can differentiate enemies, you know, by their animation, or like their sprites, their models, their animations, their functionalities. You'll notice that the wings on the Paratroopa and the Paragoomba are actually the same. Like, that's the same model of a wing applied to two different things. So, one might say that the Paragoomba multiply inherits the attributes of Goomba and of, you know, the wing. Stuff like that. I consider Yoshi to be a pickup until he has been, you know, jumped on, and then he's, you know, it's kind of funny, but, like, to me, Yoshi doesn't exist as a character because he's a pickup, you know? He's used like a pickup. Yeah, so that's, you know, roughly speaking, that's how I would do it. And, you know, I have developed video games in the past, so perhaps I have a slightly informed perspective. The way that the slides break things down... Oh, yeah, and you'd want a class for the level itself, right? So, you know, even if you just consider a level to be an arrangement of all of the other elements, that's still information, and that information should still be, like, modularized and contained, right? Like, for example, if you're using the video game development software Unity, Unity has scenes, right? And these scenes contain game objects, and each scene has a particular, arrangement of game objects as designed by you, the developer. So, yeah. Modern video game development is very object-oriented. Let's see. So coins are classes, and the interactions between characters and coins would be methods, not classes, right? If it, like, for Mario to pick up a mushroom, you would have, like, def pickup, a pickup method, right? That would be attached to probably the mushroom. But yeah. Yeah, every character has... Yeah, exactly. Even if you were to take a Mario game in which each of the various characters had slightly different jumping properties, right? Like, you know, in Mario 2, and they carried this over for Super Mario 3D World, you know, Luigi jumps a bit higher and is floatier. Mario has the normal Mario jump. Peach has the little hover ability, and Toad is like a fast runner but doesn't jump very high, right? Those are not separate, you know, run-jump methods. Those are slightly different physics variables, right? You can imagine that, you know, between Mario and Luigi, you would have a variable within their player class that would be something like jump power, right? Jump power being, you know, how high they jump, or related in some manner to how high they jump, right? And so Luigi would have slightly higher jump power, and he would also have, like, some sort of, you know, floaty ability. You know, the force of gravity would be less on him somehow, or something, right? Like, it's modifications of variables rather than the instantiation of an all-new method, right? But yeah, so that's kind of, there we go. Yeah. Basically, anything that shares a common set of attributes is probably going to be the same class. So yeah. Cool. So let's get into files. So, file. Yes, topic 9. Moving right along. So far in this course, we've been performing modifications on what we in the biz call volatile memory, right? So this is memory that does not survive your system power cycling, right? When you shut your computer off, any memory that's stored in volatile memory is lost. So this includes the active state of any program that you have open, right? And we all know this. We've all used computers. We know that if you if you turn off your computer or unplug your computer, somehow interrupt the power supply while you're working on your essay for English class, and you haven't saved your essay, the modifications that you've made to the essay are lost unless your software that you're using to write it has been configured to auto-save it every 5 minutes or so. You know, your essay will be destroyed up to the point of the previous save, right? So the difference is when you save a document, you are saving it to permanent memory. Another way of thinking about this is, generally speaking, you don't have direct access to your RAM, but your permanent memory is accessible and viewable in the form of your file system, right? All of the files on your computer are, you know, viewable and accessible by you. I have a question about classes, so let me just answer that question about classes. Is it possible to inherit methods from no class, but or from ni? So when you inherit a class and then use its method, it is definitely possible to make a sort of minor modification to it. You know, you can invoke the method as defined in the class you're inheriting from, in the same way that we were, previously in the slides, we were inheriting from, string. Here. Yeah. Colored point is using point.init inside of its own init function, right? You can use method definitions from the class you're inheriting from. So, and you should think about those as just function. You're just using the function. You can add some more functionality to that by, including additional statements within the context of this redefinition of the method. And that's, I think, what you're getting at there. So with files. So let's talk about files then. I think I'm not going to patronize you guys by going over input and print. I think we've covered those sufficiently up to now. But it's kind of it's useful to know, especially if you're interested in rigorous definitions when it comes to computer science. When you are interacting with print and input, you are actually performing file input and output, because the terminal that I always show you, it gets its characters from a file deep inside of your operating system, right? So there's generally speaking, it's called standard input and they're called standard input and standard output. There are actually three of them: standard input, standard output, and standard error. When you print something, you are placing it in a queue to be printed out on your screen. So basically, when you print Hello World, it gets written into the standard output file. That standard output file is read by in my case, my terminal, and that terminal displays the thing that's been written to standard output, and erases the thing that it prints, so that it isn't printed by everything that reads standard output from that point forward. That's what makes it a buffer. In the same way, standard input, when you enter something into the terminal, it is saved to a file called standard input. And when you call the input command, you are asking for the contents of standard input so that it can be processed by your Python file. So, printing to the screen and reading from the user are modeled by special files called standard output and standard input. In command line scripts, we can redirect standard input and standard output to files. Although this is outside the scope of this course, it's the type of thing that you would likely see in 1xC3, comp.sci 1xC3. But yeah, you can, essentially that's what a log file is. If you've heard of if you've heard of log files, it's basically just the capturing of these standard input and output buffers. So yeah, yep. Again, not going to dwell on those too awful long. Let's see. Nope. Okay. So, when you're interacting with files, generally speaking, the manner in which you do that is to open a file stream. So it's kind of similar to how the terminal works. It's kind of similar to how input and output work with respect to standard input and output. So essentially, you perform an open command. You have to select the mode in which you're opening the file, right? Generally, that's either read or write mode, but there are some other exotic modes as well. And once you have the file open, you will receive from the open command a file handle object. This is the best way to think of it is this is a link to the file stream, right? From this, they call it a file handle because it handles the files. So when you want data from the file, you ask the file handle, and the file handle goes and gets it for you and returns it to you. When you want to put stuff into a file, you send a request to the file handle, and the file handle takes the thing you want to put in the file, and it goes and it puts it in the file for you. This way, you don't actually have to worry about the actual business that your operating system goes through in, you don't have to worry about how the data transaction is actually performed. Again, this is the abstraction of functionality property that we are so concerned about with respect to computing. The file handle handles file handling. But anyway, so once you have performed all of the file operations that you wish to perform on a particular file, the final step is to close the file. And this is a very important step that sometimes people miss. So it kind of depends on your operating system, but have you ever noticed that if you're changing, or if you've got a file open in like Microsoft Word, for example, and you try to modify the name of the file while it's open in Microsoft Word, you're blocked by the operating system, and it gives you some sort of message like, this file is currently in use by another program and therefore cannot be modified. The reason that you get that error is because Microsoft Word has not closed the file handle that it's using to modify your Word document, right? So you've got the file open, and the operating system will prevent other programs from modifying something that's open by one particular program. This is actually this is a super important function of your operating system. If your operating system did not prevent two programs from saving to the same file at once, then well, let's illustrate it, right? Let's say you had a file called file.txt, right? Let's say you had it open in two different, like notepad-style text editors, right? Let's say the file originally contains, file.txt. Let's say it originally contains A, B, C, right? So when this thing is opened in two different file, actually I can do this physically on Linux, Emacs file.txt, right? So file.txt, I think it's originally going to be blank. Where's Emacs? There's one. Where's, come on. Sometimes Emacs doesn't work. Close. There we go. So save that. There we go. So we have the same file open in two different applications, right? If I make a modification in Emacs and save it, it does not automatically show up here, right? The way that Linux actually handles this is if you bring this up again, it'll say the file has been modified. Would you like to reload it? So let's imagine that we're not, right? If we then save something else, and ignore the warnings because I'm trying to demonstrate something, if we save something else, what we effectively have is two versions of the same file, but whichever one is saved last is the version that's kept, right? So because this version of the file was saved last, if we close both of these guys, and then we open the file again, you can see that the version we get is the version that was on the left, or whatever side of the screen this is for you. I think it's left for you guys. We get the left version of that file. Any information that we entered in the right-hand side is lost to history. It is completely destroyed. Generally speaking, it's bad to destroy data. That's why operating systems warn you when you're doing that, if you're Linux, and if you're in Windows, lock you out of modifying the document with more than one program at once. That's why. Maybe you guys didn't know that. Maybe you did know that, maybe you didn't know that. I don't know. This is a class, right? So the idea is at least some of the stuff is stuff that you haven't heard before. Anyway, so that's why you have to close a file handle, because closing a file handle is saying to the operating system, I am done with this file, right? If you don't close the file handle, then the operating system is never told that you're finished with the file. So Windows will just lock you out perpetually. And sometimes that'll happen if you're, for example, modifying a Word document and, Word unexpectedly crashes or something without having closed the file handle first. Sometimes you have to, perform some sort of recovery process because the file, like the operating system still thinks the file is being modified when it's not, although, restarting the computer sometimes fixes that. But anyway, so if you want to do this in Python, let's see, get it, topic 9, .py, doop-a-doop-doop-doop-doop-doo. So, file handle, fh, fh is going to be the name that we give to the object, which is returned by the open function, which is a file handle. So, file.text. Open file.text in read mode. You specify read mode by providing it an R as the second argument. String is equal to fh.read, print s, and then fh.close. This will be topic 9.py. There. Cool. Let's run that. See what we get. Python 3, topic 9.py. So there you go. As you can see, those are the contents of our file. There we go. Cool, right? If you want to see, like, the manner in which it's actually being, well, that doesn't actually work. So notice that the read function reads in the entire thing, right? The entire contents of the file, new line characters, and everything. There are various ways of reading stuff in that are different. You can read things in one line at a time, for instance, but you just need to use a slightly different method. So if you use read line instead of read, then you get a line. So if you wanted to do that like this, if you wanted to do it one line at a time, you'd do something like while s is not equal to that, I suppose. Although that might not work either, but it depends on whether they include the new line characters. We print the line and then read in the next one. Yeah. And you can see it's just inserted more new lines because it's, you know, that's how print works, right? If we modified this so that the end is just a empty string, that'd probably fix it. Yeah, there you go. So yeah, that's how you read information into a file. I see I'm out of time, so I will just give you a couple of quick notes about this. Just one warning before we go. When you read information out of a file, it will always be in string format, even if it's an integer. So, if you want it to be an integer, in the same way as you have to convert it to an integer. This is the same as the input function, right? If you take input from the input function and you expect it to be a number, you have to perform the conversion to a number manually because it's being given to you in the form of a string. The same thing is true with reading information out of files. So if there are any questions, please let me know, and I will answer them now. Otherwise, we'll see you next week. Testing, testing, testing. Is my voice still tinny? Is this still a problem? Hello, hello. Maybe I can fix it. Not sure what kind of filter you'd use for tinniness. It's not too bad, actually. Testing, testing. Hello. I sound fine? Okay. Hello. Test. Test, 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 test. I'm kind of just playing with it at this point. Sharpness filter brings out the frickin' beard hair. Look at that. Jeez. Oh my goodness. Just red. That's it. Just red. Okay. I wonder if it's possible to add reverb. Whatever. In one of your math classes last semester, we had an entire lesson with the rainbow filter on the prof scan. You know, last semester I had, like, around Halloween, I was, like, green for Halloween. It was fun. Yeah. Let's see. Filters. Color correction. There we go. I have to turn the saturation up, though. Oh my god. I didn't realize that the color of my lips was so close to the color of the sweater I'm wearing. Jeez. There we go. Well, anyway, take her easy, folks. Don't do anything I wouldn't do. Have fun, etc., etc. Bye-bye.